going to move on here in just a minute to solving two-step equations, but there's one more concept that we didn't view in the one-step equation video that I'd like to go over, and it's finding the reciprocal of your fraction, which just means to flip your fraction. And this is something that may help you or may be useful to you with more difficult equations, especially if you have coefficients that are fractions. So I want to take a look at using reciprocals when you are solving an equation. So we're just going to do this one example here together. 5 halves, or 5 over 2x, is equal to 15. Now, because that 5 halves is attached to the x, we see that, or you should view that as a multiplication problem. Typically, you would divide both sides by 5 over 2. However, taking the reciprocal of that fraction is also going to give you a coefficient of 1 with your x and solve your equation for you just the same. And so later on, when you're dealing with more difficult problems, this may be useful to you. So rather than dividing both sides by 5 halves, what we're going to do is we're actually going to take the reciprocal. So we're going to flip it. Now, when you take the reciprocal, you're no longer dividing anymore. So this is where some people make the mistake. You either divide by the number that you see, or you take the reciprocal of it and use multiplication. So here's what we're going to do. We're going to multiply this side by 2/5. Therefore, we have to multiply this side by 2/5. That is our reciprocal. And right now in your calculator, if you were to type in 2/5 times 5 over 2, you would get 1. So therefore we're left with 1x. Please don't make the mistake of trying to distribute 2/5 into this parenthesis. You cannot distribute over multiplication. You could change the order here, or the grouping, excuse me, and multiply your fractions. Think about your properties from the last unit. And then on the other side, once you multiply your 15 and your 2/5, making sure that you're multiplying, not dividing, then you should get 6. And that's your answer. So what I'd like you to do, I would like for you to try this next problem. So let's get this one written down. 12 equals 3/4 x. Now, I know you can go ahead and divide that and get your answer, but I don't want you to do that. I want you to try to solve this for x using the reciprocal method. So pause the video now and take a minute to simplify that, and then come back to check your answer. Alright, hopefully you have paused your video and you are now coming back to check your answer. The reciprocal of 3/4 is 4/3. Just flip your fraction, 4/3. So if you multiply the right hand side by 4/3, then you have to multiply the left hand side by 4/3. So that does leave us with x here on the right hand side. 3/4 times 4/3 is 1. And then on the left hand side, 4/3 times 12, you should have gotten 16. So using the reciprocal method may be helpful to you later on with more difficult equations. So now let's move on to the two-step equations. I want to review, when I say both sides of the equation, when I tell you what you do to one side of the equation, you have to do to the other side of the equation. What sides we're talking about are both sides of the equal sign. Think of the equal sign as kind of the middle of the road, or the middle of your balance, and whatever you do to one side of that equal sign, you have to do to the other side. So make sure that if you're adding 5, for example, that you move over to the other side of the equal sign before adding 5 again. You have to keep everything balanced. So let's move on to our two-step equations. To solve a two-step equation, this is very important. You have to identify the operations, which I do see that I have a spelling mistake here, so we could fix that real quick. Identify the operations being used and undo them using the inverse operations. You must use the order of operations in reverse order. So you are used to doing multiplication and division straight across and then addition or subtraction. So now we're going to have to go in reverse. Alright, so let's look at our first example here. Let's look at 2x plus 11 equals 51. What you need to do whenever you're trying to solve these problems is you need to look at what's happening, identify the operations being used. So look at what's happening to your x. There are two things, two-step equation here, there are two things that's happening. First, I am multiplying x by 2, and then I'm adding 11. Thinking of order of operations, I would multiply this number and then I would add 11 to that. So if we're going to solve this equation, then we need to go in reverse order. Instead of multiplying, we need to start with the addition. Now, just like we learned with our one-step equation, to move this to the other side of the equal sign or to remove it from this side, we have to do the opposite operation. So instead of adding 11, first thing we need to do is subtract 11. So be very careful. Notice that I moved to the other side of the equal sign to subtract my 11. I'm not subtracting 11 over here 2 times, just once. The positive 11 minus 11, that gives us our 0, which is the point of doing the opposite operation. So that leaves us with 2x equals, and then you just have a simple subtraction problem there, 51 minus 11, which gives you 40. Alright, so I'm actually going to move my problem up here. Since I'm running out of room, I'm going to rewrite this so that we can see, identify what to do next. We have our 2x equals 40. So now we're down to a one-step equation just like you had on the last video. The 2 is attached to the x here. Remember, you need to visualize this, that this is a multiplication problem. So the opposite of that, or the inverse, would be to divide both sides by 2. So move to either side of the equal sign. Dividing by 2. 2 divided by 2 gives me 1. So I'm left with that 1x, which is necessary. You have to have that variable alone. Isolate the variable, which means get the variable by itself on one side. And then you have 40 divided by 2, which is 20. Very simple two-step equation. So now I want you to jot down this problem, and I want you to try this one. 5 equals t over 2 minus 3. Write this down, then pause the video and take a minute to solve this for t, and then come back to check your answer. Alright, hopefully you've paused the video and you have solved this equation for t. If you feel good about it, move on. If not, you need to follow along with me. The two operations that we're using here with t, first we're dividing t by 2, and then we are subtracting 3. So thinking order of operations backwards, we need to remove this subtraction first. Inverse operation of subtracting 3 is to add 3. So I'm going to add 3 on the right hand side of my equal sign. And then I'm going to move over to the left hand side and add 3 there also. Alright, so 5 plus 3, very simple addition problem. That gives me 8. Notice I'm still left with my t over 2. I haven't worked with that yet, but my negative 3, or my minus 3, we can also recognize that as negative 3. Those two are interchangeable there. Negative 3 plus 3 gives me the 0 that I need. And from here, different from the problem that we did together, from here I am dividing by 2, so the inverse operation of division would be multiplication. And we talked about this with our 2-step, that multiplying by 2 is the same thing as multiplying by 2 over 1. We could make that into a fraction if we wanted to. But to shorten the work here, we can just multiply by 2. Move my video here so you can see a little bit. Multiply this by 2. 2 times 8, that gives me 16. Over here, the division of 2 and multiplication of 2, their opposite or inverse operations, will give you the 1t necessary for your problem. And there's your answer. Alright, so let's move on to word problems. Here is a word problem. And in this word problem, we just need to be able to identify the unknown, what it is that we're actually looking for, and what operations we are using within our equation in order to write an equation from this word problem. So we have a train traveling, it's 100 miles away from a station. It's approaching the station at 40 miles per hour. We want to know how long will it take for the train to arrive. Well, first of all, we have 100 miles away, so there's a distance, and then we're traveling 40 miles per hour, so that's a rate. And hopefully you would recognize there is the formula distance equals rate times time. Hopefully that is familiar to you, that you've seen that before. So we're going to use this formula and actually write our equation based on that formula. Distance equals rate times time. We know the distance in this problem. That is our 100 that we have in yellow up there. And that equals the rate, which we do actually know in this problem as well. That's our 40 miles per hour. So think to yourself, what's the one thing I don't know? The one thing you don't know is t. So you could identify t over here. T is time. How long is it going to take the train to arrive? And that's what it wants to know. How long will it take for the train? So, simple problem here. One-step equation actually. We've got 40 multiplied by t, so the inverse operation would be to divide both sides by 40. 100 divided by 40 gives you 2.5, which is t. So it's going to take approximately 2.5, and when you're dealing with word problems, you need to make sure you have your units there. It's going to take approximately 2.5 hours. Alright, there is a few more examples that we will want to discuss on solving two-step equations. We'll do that one when we get to multi-step equations, which will probably be in 2 parts, a 2-part video. So what I would like for you to do right now is to write down this summary. How can you determine a good first step in solving a two-step equation? So make sure in your notes over solving two-step equations that you answer this summary question. It might be good practice to actually write the question and then write your answer beneath it. And if you need any extra practice, make sure that you look at your checklist and you go to the section and pages that are there on your checklist that match up with solving two-step equations. There are other examples, and there's also extra practice problems that you can do if you're still unsure of how to solve two-step equations.